Welcome to Conceptual Cambridge. This is part 2 of the trigonometry video. So let's begin with transformation. As you can see, I've taken two graphs. One is y is equal to sine of x and the other is y is equal to 2 sine of x. So let's discuss the difference first. The difference is only that I've multiplied the sine of x by 2 in the second graph. So the change that is going to happen is only going to happen in the y value or in the y direction. For example, as you can see, the x values are still, the graph is still being completed at 360. Both graphs are being completed at 360, but the y values of the first graph is 1, the maximum and minimum is 1 and minus 1, and for the second graph it is 2 and minus 2. So the only thing that this 2 sine of x is doing is that first of all it is applying the function sine of x, and then 2 is multiplying it, 2 is being multiplied with it. So for example, if I was to take the value x is equal to 45, so first of all I'm going to find out sine of 45, which is 0.7. Now I'm going to multiply it by 2, 2 into 0.7, which gives me 1.4. This is only affecting the y value. Even if it was 3, 4, 5, or it was being divided, it will only affect the y value. Or for example, it was something like 1 plus sine of x. This will also only affect the y values or minus. So for example, let's take 45 again. So 1 plus sine of 45. At sine of 45 we have the value 0.7. So this is 1 plus 0.7, which means I get 1.7. So only the y values are being affected. There is no change in the x values. Now let's check out the other transformation. So now as you can see, I've taken another graph which is y is equal to sine of x and y is equal to sine 2 of x. So the only value that is being affected is going to be the x values over here, as the 2 is inside the function. So basically what is this going to do? We are going to discuss that. As you can see, we are just going to use the original graph and repeat the same thing. Y is equal to 2 sine of 2 into what was the x. Let's take for example 90. So we have 2 into 90, which gives me sine of 180, and at sine of 180 we have the value of 0. So as you can see, I took the x value of 90, and at 90 you can see we have 0. So this is just going to affect the period of the graph or the repetition of the graph, how fast or how slow a graph is going to be completed. So for example, what is happening to the period? Now let's discuss it. So for example, in the above graph, you can see the period starts from here and ends at 360. So 0 to 360, one period is being completed. Now for the second graph, let's see what is happening. The period starts from 0 and let's say it ends at 180. So as you can see, the period for the first graph is 360 and the period for the second graph is 180. The period is being divided by 2. 360 over 2 is equal to 180. What this means is that, for example, even if it was sine 3x, what this will do is divide 360 by 3. It will change the period by the value that is written inside the bracket and is being multiplied by x. So the graph has shrunken and the graph will be completed faster. Why? Because for example, as you can see, the graph ends at 360 at the first place, but the 180 is going to be multiplied by 2 in second graph, and that is going to give me sine of 360. This is why the graph is being completed faster in second, and two graphs are being made in the second, as you can see, two repetitions. Let's check out the other transformation. So again, only the x values are going to be affected. As you can see, y is equal to sine x plus 90 we have over here, and we are going to use the same logic. So for example, if I was to take 90 as my x, so what this is going to do is just sine 90 plus 90, which gives me sine of 180. At sine of 180 I have 0, so what this means is at my 90 value there is going to be 0. So basically what is this sine x plus 90 doing? Basically, as you can see over here, the graph is being moved to the left. So for example, first of all it was beginning at 0 and ending at 360. Now it is beginning at minus 90 and it's going to end at 270. So the graph has moved to the left. As you can see, if I was to input sine of 270 plus 90, this gives me sine of 360. Hence my graph will be completed at 270. As you can see over here, at 270 my graph is being completed. This is basically what it means. Now let's move on. Now here we have trig identities. This will be given to you in the formula sheet, but just in case, let's discuss them. So for example, here we have tan theta is equal to sine theta over cos theta. So why is that? So as you remember, so Cartoa, let me just write it out. So what does this mean? This means that tan is equal to opposite over adjacent, right? So alright, just remember that. So now let's see, sine of x is equal to opposite over hypotenuse, and cos of x is equal to adjacent over hypotenuse. So if I was to do this, divide sine of x by cos of x divided by cos of x, which is adjacent over hypotenuse, this should be opposite over hypotenuse multiplied by hypotenuse over adjacent. So as you can see over here, this gives me opposite over adjacent. This is why this identity exists, and this will already be given to you in the paper, so no need to memorize it. Now moving on to the second identity. So here we have cos square theta plus sin square theta is equal to 1. So for example, let's take any theta and see why. So for example, if I was to take 0, as you can see I've taken 0 from both. So what this does is cos square theta plus sin square theta is equal to 1. In the graph of cos square I have the value 1, so 1 plus, and at sin square I have the value 0, which equals to 1. Or you can take any other value, for example 45, you can see it has 0.5, and same with the other graph 0.5. You can just see this from the graph and understand it. This will also be given to you already in the formula sheet, so no need to memorize this either. Let's move on. So now here we have proving identities. Let me first of all rewrite this in the fractional form. So 1 plus sine of x over cos of x plus cos of x over 1 plus sine of x is equal to 2 over cos of x. This is what you need to prove. So first of all, let's make them into a common denominator. To do that, let's multiply this both sides by 1 plus sine of x, and let's multiply this both sides by cos of x. So I get 1 plus sine of x squared plus cos square x over 1 plus sine of x into cos of x. Let's try and open it. So 1 plus sine x square will be opened into 1 square plus sine of x plus sine of x, which means plus 2 sine of x plus sine square x, and now plus cos square x over cos of x plus sine of x cos of x. So now let's see what we can do over here. We can use the identity sine square x plus cos square x is equal to 1, as you can see over here. So let's try and apply that. So 1 plus 2 sine of x plus 1 over cos of x plus sine of x cos x. Alright, now we can rewrite this as 2 plus 2 sine of x over cos x plus sine x cos x. So now let's try to find a way to make this into 2 over cos of x. So let's see, if I was to take 2 common in the above fraction, this will give me 2 into 1 plus sine of x, and then I can just do the same cos of x into 1 plus sine of x. Now these two things can cancel out. This gives me 2 over cos of x, hence proven. So here I have taken another question from the book, and we are going to solve this using the trig identities. So since we want our answer in terms of cos of x, you know the trig identity, and we have everything in squares, so we know the identity sine square x plus cos square x is equal to 1. We can change this or modify this to be, for example, let's say cos square x is equal to 1 minus sine square x. Or since we want our answer in cos of x, we need to modify it like this. Sine square x is equal to 1 minus cos square x. Now we can input this into our question. 4 cos square x minus 3, and instead of sine square x we can write 1 minus cos square x. Now let's open it. So we have 4 cos square x minus 3 plus 3 cos square x. Now we have 7 cos square x minus 3. This is going to be our answer. So I'm going to end the video over here, and now we are going to solve topical questions from this topic. Alright.